So we got the minimum of the Rosenbrock function using Broyden's method and the Sherman-Morrison formula, but what if we want to minimize the Rosenbrock function subject to a constraint? So say we just have one constraint and the function with the two variables, and then we took the partial derivatives of that function like we did for the Rosenbrock. Um, well, then we'd have three equations, our two partial derivatives and the constraint, but only two variables because our constraint is also a function of those two variables. So one thing you can do to fix this problem is to introduce a new variable called the Lagrange multiplier and then the Lagrangian. So let me pull this up. Okay. So what this says is you take your function f, which is the function that you're wanting to either maximize or minimize, which we're minimizing in this function, minus um, your constraint g times this Lagrange multiplier. So geometrically what this is saying, pull this up, we have this function f that has these contour lines here. And then we have our constraint represented by this red line here. Well, if we look at the gradients, which are these perpendicular lines to the function, those are the gradients of the function. And then we also look at the gradients, these perpendicular lines to the constraint. We see that the gradients match up right here at the minimum of our function that satisfies this constraint. Or I'm sorry, which with respect to the constraint. So for the function to satisfy the constraint we have here, the gradient of the constraint g must be collinear, like we see here, with that of the function, but they don't have to be of the same magnitude. So that is why in the equation you multiply the constraint by the Lagrange multiplier. So that is how you would implement the constraint if it was an equality constraint, or yes, if it was an equality constraint. But say we have an inequality constraint. Well, now we need to introduce a slack variable, which is saying that you just add on some arbitrary value to fill in the gap between each side of the inequality. So you're able to then convert the inequality to an equality constraint, which you can code in Python. And then you would just set that constraint to equal 0. So that is how if you have an inequality constraint, you use the Lagrangian and in conjunction with a slack variable to fill in that gap and get your equality constraint and then code it.